In this video, we're going to discuss a third algorithm to select candidate hyperparameters called random search. As the name indicates, in random search, hyperparameter values are selected by independent draws from a uniform distribution of the hyperparameter space. Or in plain English, random search selects the combinations of hyperparameters at random from all the possible combinations given a certain hyperparameter space. Now, just to recap with an illustration, if we have two hyperparameters and we want to sample three values of these hyperparameters, with a grid search, we will examine all possible combinations of these three values, as we see here, but with a random search, we will examine some of those combinations, and these combinations would be selected at random. The user determines how many of the total combinations we should examine. Now, why is random search so effective? If you remember from previous videos, we have something called the low effective dimension. And this means that some parameters affect the model performance a lot and others not so much. So for example, in the case of gradient boosted machines, the number of trees affect the performance quite dramatically, but the minimum samples per split not so much. This offers a random search an advantage over grid search. Now imagine, as I show in this illustration, that we have a very important hyperparameter which takes continuous values, and then non-important hyperparameter also with continuous values. Now in a grid search, first we need to specify which values of each hyperparameter we want to sample, and then the grid will establish all possible combinations of those given values and examine them all. Now, if the important hyperparameter is this, we would imagine that the performance of these three algorithms would be fairly similar to the performance of these three, because this dimension is not so important, and these three would be also very similar to the importance of these three, and the models would increase performance towards the right of this plot. So these three models would exhibit a similar performance. Now, because the grid search searches pre-established combinations, at the end of the day we don't know if a value in this area or a value in this area would perform better than the value that we entered into the grid. Now with random search, the values to explore are selected at random. So it would establish random combinations of the important and the non-important hyperparameter. Therefore, by selecting at random, it would explore more dimensions of this important hyperparameter, as you see here. So now we are able to explore these values, for example, that we weren't able to explore before with the grid search. So a random search allows the exploration of more dimensions of the important hyperparameter. It of course allows also the exploration of more dimensions of the non-important hyperparameter. But because this dimension is not important, what we really need is to explore this dimension. Whereas grid search wastes time exploring non-important dimensions like these dimensions over here. The other important feature of random search is that it selects the values for the hyperparameters from a distribution of values and not anymore from a manually defined grid as we do for the grid search. Therefore, random search is suitable for continuous hyperparameters. So to summarize, the random search can be parallelized just as grid search. It shows high efficiency in high-dimensional spaces because it's able to explore more dimensions of each hyperparameter, and it is well suited for continuous hyperparameters precisely for this reason. As a trade-off, there is a small reduction in efficiency in low-dimensional hyperparameter spaces. So the message here is that if we have high-dimensional hyperparameter spaces, we are better equipped if we do a random search, but for small dimensional spaces, grid search works well enough. Just to wrap up the comparison between grid and random search, we know that both can be parallelized We know that random search is effective in high-dimensional spaces, whereas grid search is not, it's just too computationally costly. But grid search is effective in low hyperparameter dimensions. For random search, it kind of depends on the number of combinations that we're willing to sample. Random search is well suited for continuous hyperparameters, whereas grid search is not. And for grid search, we need to define the hyperparameters manually, whereas a random search is able to draw the hyperparameter values from a distribution. Therefore, it's able to explore a wider hyperparameter space. There are a few things that we need to consider when we implement random search. The first one is that we can choose a computational budget independently of the number of hyperparameters and the possible values of these hyperparameters. And here I put ish because, of course, it's not the same to optimize hyperparameters for a neural network than for a gradient-boosted machine, right? Neural networks have a lot of hyperparameter and hyperparameter values, so we probably need a higher computational budget. But given a certain algorithm, we would choose a budget regardless of the number of hyperparameters, because in a random search, adding more hyperparameters or more values does not influence the performance of the search much. It does not decrease the efficiency of the search, provided we allow enough iterations of the search. So, provided we allow the search to explore the hyperparameter space well enough. And the other important aspect is that instead of determining the values of the hyperparameters manually, to take the full advantage of the randomization, we need to specify continuous distributions of the possible values of the hyperparameters. Now, going back to how many iterations of the random search we need to allow, there is a probabilistic explanation that suggests that with 60 extractions at random of combinations of hyperparameters, we have 95% probability of finding the combination that returns a maximum performing algorithm. In the next video, we're going to see how to implement random search with scikit-learn. That is all for now.